All right, so what we're going to do today is finish off 3.4 and then see how you all understand this. So again, we're writing quadratic functions in Vertex factored and standard form. And we're going to be able to find all the roots of the quadratic, use roots of a quadratic function to write the function in factored form. And then here are some questions that we have. Okay, so we already did a couple of these. If you remember here, we got it in vertex form by completing this. No, did we? No, by grabbing the vertex, right? Here we got it in factored form. What do you need in order to build factored form? What do you need in order to build factored form? What do you need in order to build factored form? You guys remember? How did we build this right here? Oh, I just noticed that this is wrong. This should be x plus 3 and x plus 1. Why does this say -3? You guys, this is wrong. Oh, no, I know why. Haha, I'm so sorry. This is, yeah, we build it off the x-intercepts. I don't know why. I was staring at this and I'm like, why is this wrong? But we should be using our x-intercepts. So -3 and 1. So we put -3 and -1 here. And then we rewrote it so it is x plus 3, x plus 1, right? And then so we finally have our answer there. Okay, so here we did the same exact thing. We use, I don't know why this is gigantic. We use the vertex to build the vertex form, which is right here. Well, here's A. Oh, it must be to the right a little bit. And then we grabbed the factors and we were able to write the factored form and the standard form. Factored form looks crazy when our roots are crazy, right? Here's our roots. Our roots are crazy. See, it's in between, right? So therefore our factored form looks a little on the crazy side, but still, you know, it makes sense. Same thing goes here. This one was a little bit more straightforward because the vertex was nice, the intercepts were nice, right? And then we're going to continue using this one. Now, this one is a little bit different because you just told me that the factored form, I need to use x-intercepts, right? You just told me that. But then you're like, hey, Miss Johnson, this one doesn't have any x-intercepts. It doesn't touch the x-axis at all. So I'm like, yeah, so how are we going to write that factored form? So right, for now, I will say for now, we can't write a factored form right now. But after the next lesson, we will be able to write factored form. So can you start me off by just telling me what I would need in order to build my vertex form? What would I need in order to build my vertex form? What would I need? Very good. I need the vertex. And the vertex, according to this, is -2, 1, right? -2, 1. So in my vertex form, I write, okay, Miss Johnson, it's 1 second. No. -2, 1. And then I'm going to use that form that we have up here to build our equation. So if you don't remember this form, no problem. Just make sure that you have it handy and you know where to look for your vertex form. So I'm going to take my vertex and plug it in here. So can you take a second to do that? This is pencil to paper, meaning like this. Yeah, I figured. Don't worry. I know you guys type really fast. This is pencil to paper. This is like one of those things that looks super complicated, but then when you actually do it, it's really doable. So I'm going to pause the video. You're going to plug in your vertex. And then once you have your vertex, my next question is, okay, but how do I find A? So if you can do that really quick, that would be fantastic. So I'm going to pause the video real quick and come back and check. So I gave you some time to check. So you should have put your vertex in as here, -2 and 1. So I'm just going to copy all that down. It's going to go with why my iPad is going cuckoo right now. Hold on a second. Oh, what is happening? Hold on, let me unplug this. Maybe that'll work. All right. Sorry, I'm scrolling. All right, here we go. So I would write a parentheses x minus parentheses squared plus equals to y. And then I'm putting my -2 in there and my 1, right? So then what happens is this changes to x plus 2. I'm just going to clean this up a little bit. So x plus 2 quantity squared times a plus 1 equals to y, right? So now what I'm going to do is now I need to look for a. How do I find a? What should I do? How do I find a? Anybody know how I should find a? How should I find a? What did we do to find a? So if you don't remember, scroll back up here. What did I do to find a? So I had this and I didn't know. And then all of a sudden I have a 0.02. What did I do? Yes, you plug in a point. You plug in any of these points. So I would plug in probably this 0.5 is probably the one that I'd plug in because it's a 0. Zeros are my favorite. So I'm going to plug in the 0.5 here. So everything stays the same. A parentheses plus 2 squared plus 1 equals 2. And then instead of putting x, I'm going to put 0. And instead of y, I'm going to put 5. Okay. So far, so good. I know you guys are like, wait, I remember this. Plug in my vertex. I get this. Plug in a point. Now I'm trying to find y. So here I get 2 squared, which is 4a plus 1 equals to 5. And then I would just solve, right? You should be comfortable saying, okay, well, if that's true, then 4a equals to 4, therefore a equals to 1. And you're like, oh, Ms. Johnson, it seems like a always equals to 1. That's true for right now. And then what I do is I plug all of my stuff in to give me a final vertex form equation. So a is 1. I don't need to write it. Then I would write x plus 2 quantity squared plus 1 equals to y. So there's my vertex form. Okay. Now for factored form, I can't come up with factored form because here I would usually just pick out my roots, but I don't have my roots. I don't have my x-intercepts. So here I can't do this yet. So I'm going to write not yet. Okay. So later on you will be able to do this, but for now you can't do this, not yet. Right. So then how will I find standard form? So remember, standard form is like that regular looking, where's my standard form? Here, it's over here. Standard form looks like this, right? Where it's all multiplied out. So how am I going to grab standard form if this is all I have? What should I do now? What should I do here? What should I do? What could I do? I guess I should say, what could I do? What could I do to this thing? Hint, hint. What could I do to this thing? Uh-oh, do we not know? Look at this. And I want to get this into ax squared plus bx plus, I want it all multiplied out. What could I do here? No, not yet. What could I do? So is looking at this, if I said, do something to this, what would you do? Yeah, I would just multiply this out, right? So I would multiply this out first. So very good. So I go y equals x plus 2 quantity squared plus 1. So I would box this out, right? X plus 2, x plus 2. Now, some of you can do this in your head. That's great. So, and then I would add 1 to it. Uh-oh, it's not showing up. Give it a second. Hold on a second. Oh, there it goes. So what I would do is I would multiply this out, right? Because what I want this to look like is I want it to look like ax squared plus bx plus c. So right here, I multiplied it out. I multiplied x plus 2 times x plus 2. So now I want it in standard form. Someone help me out with standard form. Y equals to what? Y equals to what? Nope. Okay, now look at all this. You got to collect your like terms. So what could you do? Yeah. So y equals to x squared, good, plus 4x, good. And then I want to go plus 4 plus 1. So how much is that going to be? Very good. Yeah, plus 5. Very good. So here's what I want to kind of give you an analogy of. No matter where you are here, I need you to be able to get to wherever you need to get to. So here we found vertex form. Would you be able to find standard form from vertex form? And you guys are like, yes. So how do you do that? You just multiply and then you add all these like terms. Does that make sense? You guys okay with this? Warming up it a bit? Okay. So that's how you find standard and vertex form. I can't show you how to find factored form until I show you a couple more things. So the reason why that is, well, I'll show you in a little bit. So Israel was concerned that his factored form for the function in problem 4 didn't quite look right. So in this one, it didn't look right. So let's see. Because I can't pull off my x-intercepts, I could also say, okay, well, when does this equal to 0? So I'm going to pause on factored form for just a little bit, just so you guys can see where I'm headed with this. Okay. So here, we'll move on to the next one. It says, why might Israel be concerned about writing the factored form in problem 4? It's because, tell me, why would he be concerned about this? What doesn't he have? What doesn't he have? Very good. He doesn't have x-intercepts. So earlier, you would just write it as, if this was your intercept, you write it as x plus 2 up here, because these were your two intercepts here. Remember, we wrote it like this. Looks like this, right? It looks kind of funny, right? So when we're trying to write the factored form for number 4, it looks kind of funny. Okay. So here's actually why. So what we're essentially doing is we're going to solve this for equals to 0, because that's when when we say x-intercept, we mean y equals to 0. So I'm going to take this equation over here, and I'm going to write x plus 2 squared plus 1 equals to y, but I want this to be 0 because I want to find the y-intercept, the x-intercepts. So I'm going to write this as a 0. So what would you tell me to do first? How would I solve this? How would I solve this problem? What would you tell me to do first here? What's the first thing that I should do? Yeah, I'd subtract 1, right? We're SADMEPing, guys, right? You guys remember SADMEP? SADMEP goes like this. All right, start with on the X side. Do you see any subtraction or addition? Right, SADMEP is PEMDAS backwards, in case you're new, you forgot. So is there any subtraction or addition on this side? Is there any, yeah, there's addition, add 1. Some of you are like, oh, but Ms. Johnson, that plus 2, but he's stuck in parentheses. right? He's stuck in parentheses and we can't skip steps, right? So how do I undo adding 1? How do I undo adding 1? Yeah, we subtract 1. Very good. So we subtract 1. And so what do we have left? X plus 2 quantity squared equals to -1. Okay. Very good. Very good. Very good. So what would we do next? What would we do next? Very good. We would take the square root. Now, here's something. What is Miss Johnson going to say? Don't forget what? What is Miss Johnson going to tell you right now? Don't forget what? Yes. Oh my gosh. I'm so excited right now. Everybody remembers. Very good. So don't forget your plus or minus. Okay. So go ahead and take the square roots while my computer catches up to you all, because you all are faster than my computer, which is awesome. So you're going to put a plus or minus. Plus or minus. So don't forget that plus or minus. Very good. Thank you for saying that. I'm so excited right now. I feel like I, as a teacher, have accomplished much greatness when you guys remember those things. Very good. So for some reason, it's not, oh, there it goes. So here's your square root. Do not forget your plus or minus. So I'm going to put a pretty big plus or minus there so everyone sees my plus or minus. And then here's what happens. These two undo and we get x plus 2 equals to the plus or minus of the square root of -1. Does anybody see anything funny, weird, strange? I don't know. Does anybody see anything that's weird or strange? Does anybody see anything strange? Strange. I see something strange, Miss Johnson. What do you see that's strange? Yeah, that square root of a -1 is weird, right? The square root of -1 is weird. Now, the reason why it's weird is because if you think about square roots, I can't get a negative. So this is weird. And there's more on this later. Just know that this is weird. Okay, so let's pretend that it's just normal. Let's just ignore him for now and see what we could do. So how would you finish solving for x? How would you finish solving for x? What would you do? Very good. Subtract 2. Very good. You guys already knew my question. Loving this. X minus 2 plus or minus the square root of -1. Now this is weird. Again, I will say this is weird. This is weird, which makes sense why this is weird, because look, technically, Miss Johnson, he doesn't have an x-intercept. So it was bound to be something weird because he's not touching the x-axis. Okay. So now technically I can write the factored form. So let me show you how to write the factored form one more time. Let me show you up here. When we write the factored form, I don't know why this is so zoomed in. There it goes. When we write the factored form, we use this formula here. And I'm just going to show you a different way because maybe it'll make more sense to you. Okay. So I'm just going to show you a little bit of a different way for factored form. So the first thing that I'm going to do when I want to write something in factored form is I start with the roots, right? So here's x is equal to -2 plus square root of -1. And I'm going to separate these. X is equal to -2 minus the square root of -1. So I just separated this into its positive and the negative versions. Okay. These two numbers actually have a name, and I need to talk about their name really quick. So these are called conjugates. Okay. So the word conjugate, or if we say it like if we're conjugating a verb in Spanish, is the same. It's kind of, it reminds me of that. Okay. So it's -2 plus square root of -1 and -2 minus square root of -1. Now, I want you to pay attention to what's the same and what's different between these two. What's the same and what's different? Okay. When you conjugate a verb, I'm going to take you to Spanish class really quick. Yeah, very good. The difference is this plus and the minus. Very good. What's the same? Man, you guys are on it today. Very good. The same is the numbers, -2, square root of -1, square root of -1. Very good. The numbers are the same. So when you conjugate a verb, I'm going to take you to Spanish class really quick. Like if you conjugate the word comer, right? It's como, comes, come, comemos, comen, right? So the COM stays, and then you change the ending based on who is eating, right? So same thing goes here. Our numbers stay the same, but instead of the ending changing, the operation changes. Okay, so these are called conjugates. Something very cool happens with conjugates. I'll show you later, but not right now. But I wanted to get you to here. So when we're using like, pretend that these are our answers, and I just came from factored form. The line above this, right, would be equals to 0. So I want you to think about, and I want to move this down actually. I want you to think about going backwards. And so that the line above this would say blah, blah, blah equals to 0, right? Right? So I want to basically get everybody on the X side. So what could I do to this or this and this so that it equals to 0? So this, I want to move this stuff on this side. What would I do? What could I do? What could I do? What could I do? How could I move the -2 or -2 to the other side? What would I do? Just the -2. What would I do? I don't want it. So this is very algebra, right? Algebra says, I don't like the way it looks. I want it to be equal to 0. So I want all these people to move to the other side. How would you move -2 to the other side? Yeah, you'd add 2. Okay, so you want me to add 2 to both sides, Ms. Johnson? Yeah. So then I get x plus 2. But can I move this guy too? How would I move him? How would I move the plus square root of -1? Very good, by the way. Thank you for taking a risk. Awesome work. Yeah, I would just subtract square root of -1. Very good. So I'm going to subtract square root of -1 at the same time. And then I would get this thing. Do you see how I'm going to get x plus 2 minus the square root of -1 equals to 0? So that's that. So I'm going to just copy this here. Okay, can you try to do that one? Can you try to do this one right here? Do the same thing so that it equals to 0. How would you move these guys over? I'm going to pause and you're going to pause and you're going to try this on your own. Pencil to paper. Ready? Go ahead and go. So you had some time to do it. So how would I move this -2 over to the other side? What would I do? How would I move this -2 over to the other side? What could I do? Very good. So I would add 2, and what else could I do? Very good, very good. Very good. So add 2 to both sides. What else should I do? Very good. Add the square root of -1. Add the square root of -1. So here I should get x plus 2 plus square root of -1, which makes sense because look, plus 2 minus square root of -1 plus 2 plus square root of -1. They kind of still held their like conjugate. Do you guys all see how that worked? Very good. Okay. So then in factored form, the last thing is I would just take these two pieces and put them inside factors in parentheses. Does that make sense? So it's almost like you're going in reverse order to do this. Okay, so wait, what, Ms. Johnson? So like pretend I gave you this equation like this and I said, okay, I want you to solve for x. Do you see how first you would separate it out to be equal to 0? And then do you see how you would move everybody away from x? So do you see how you're just undoing that? So here's factored form. You're done. Okay. That's why Israel was so concerned. he's concerned because look, it's a square root of a -1. It's weird, right? All right, so we answered that. Here's some more work. So here, I'd like us to try, let's see. Let's try one more. Let's see. Actually, I'm not going to have you guys try one more because we've done a little bit. If you would like to try these on your own, great. But I need to move on to this next part. So Miriam notices the graphs of problems 7 and 8 have the same vertex, and Israel notices the graphs of the functions in problem 2 and 7 are mirror images across the x-axis. What do you notice about problem 7, 8, and 2? And we didn't do 7, 8, and 2, but if you notice, these kind of look similar to a couple of those, but you're not missing anything. But I did want to talk about this fundamental theorem of algebra. So the fundamental theorem of algebra says a polynomial that has this, just look at this as ax squared plus bx plus c, okay, because that's what we're working on. As the theory of finding roots of a polynomial function evolved, a 17th century mathematician, Girard, made the following claim that's known to be known as the fundamental theorem of algebra. A nth degree polynomial has n roots. So wait, what are you saying, Ms. Johnson? So the fact that these are all like x squared, it means that I should have 2 roots. And look, we do have 2 roots. The roots happen to be like funky looking because there's a square root, but we'll talk about more of that in a little bit here. But hey, Ms. Johnson, this one doesn't have 2 roots. So technically it does, right? Its 2 roots are -2 and -2. And you're like, Ms. Johnson, like that's the same number. It just really has 1 root. So we actually say that this is 2 roots because this is actually 2 roots because it hits it twice, right? So you would say equals to 0. Do you see how you would have the equation x is equal to -2 and x is equal to -2? You'd have it twice. So that's the big portion about the fundamental theorem of algebra that is really important. So if I have a cubic, like next year, you'll learn about cubics. I know this because this is exactly what I just taught to the integrated 3 students. When we have a cubic, you should be looking for how many roots. So if it's x to the 3rd, how many roots should you have? X to the 3rd, how many roots should you have according to this theorem? Yeah, exactly. 3. I should have 3 roots, Ms. Johnson. Where'd the 3 come from? Anybody know where the 3 comes from? From your highest power. So if we have x to the 5th is the highest power, then I should be looking for 5 roots. If I have x squared, I should be looking for 2 roots. Does that make sense? Are you guys okay with that? Okay, let's try this again. So let's say I have a polynomial and it's, I'm just going to try to make it very concrete for you here. Let's say I have a polynomial and it looks crazy. It's like 6x to the 7th minus 12x to the 4th plus 7. Okay, I have this crazy looking polynomial here. You're like, Ms. Johnson, it's x to the 7th. Are you crazy? Not really. Okay. How many roots should I look for? How many roots should I look for? No, not 3. Good guess though. I like it. Try again, guys. How many roots should I look for? What's the highest power? What's the highest x? X to the what? Very good. To the 7. Very good. So how many roots should I be looking for? Very good. I should be looking for 7. Why, Ms. Johnson? Because the fundamental theorem of algebra told me to, right? The fundamental theorem of algebra says an nth degree polynomial. So what degree polynomial is this? Look at your power. What's the highest power of x? You guys all say 7, Ms. Johnson. It's a 7th degree polynomial, right? Has n roots. So how many roots does this have? 7. Okay. So I'm going to be trying to slick. I want to be slick here. What if I put 100 here? What if I put 100 as the power? How many roots should I look for now? Yes, 100. Ms. Johnson, are you going to make us do that? No, no, I've actually never done that before, myself. Okay, so hopefully you see here, it's a little bit of a review to find the vertex form. And then also more on this part here with the square root of a -1 coming soon, coming very, very soon, actually. So check that video out as well.